All right. So let's talk about what is a complex fraction. So let's write this down right here. Okay, complex fraction. So a complex fraction is a fraction where the numerator and or denominator contain one or more fractions. Okay? So once again, a complex fraction is essentially when you have a fraction inside of another fraction, which can be quite difficult because how do you do a fraction when it's inside of another fraction? Like, how does that work? Well, we're going to find out today. Go ahead and write this down, and then I'll show you an example in just a second. You can just follow along. I have an empty seat over here. If you want to sit closer, it's an empty seat right there. I'm going to sit closer to the board. You good? Okay. All right, so let's take a look at an example and see what we can do here. I would like to give you guys a general overview of how to perform an operation with a complex fraction. So why don't we look at this? Let's say that I have a over b. I have a fraction a over b. But that is the numerator for a fraction c over d. So this itself is a complex fraction because my numerator is a fraction and so is my denominator a fraction. So then how do we go about this? Well, this is what you have to do. You have to first of all identify that you have two separate fractions. This is a fraction and this is a fraction. Now, a fraction over a fraction, let's think about what fraction means operation-wise. What operation am I doing when I have a fraction? Am I adding, subtracting, multiplying, or dividing? What do you think I'm doing? I'm dividing. So I'm dividing the top by the bottom. So what we're going to do is we're going to rewrite this. And instead of writing it as a fraction, we're going to write this with the old-fashioned division symbol. A over B divided by C over D. Okay, now this looks more manageable. A over B divided by C over D. And once again, we're looking at, these two fractions. Okay. Well, if I'm dividing two fractions, now I can okay, I remember this from fourth grade. I have to keep change flip, right? So then I keep my first fraction as A over B. I change my division sign to what? Multiplication. And now I flip C over D. So the bottom goes to the top, top goes to the bottom. And I have D over C, right? Keep change flip. And then my final answer is the product of the top and the product of the bottom. So A, D over B, C. So this is very general. I'm generalizing right now the steps. This is basically what the approach will be for all problems that deal with a complex fraction. But this being pre-calc, we're gonna throw some variables in there, and it's gonna start getting a little messy. But let's do a problem with some numbers. All right, so keep this in mind. I want you to refer to this. This is the general approach. And I want you guys to refer to this anytime you're doing a complex fraction. Because now I'm going to give you an example with some actual numbers. So it'll be kind of easy because they're just numbers, but you got to get the idea. Okay, so we're all good with this? Give me a thumbs up if you're done writing this. All right, cool. Okay, so let's take a look at an actual example now with some numbers. So let's say I have the following. 8 over 5 divided by 25 over 4. Once again, 8 over 5 divided by 25 over 4. So how can I rewrite this? I want to do the first step, like, following the general approach. I want to change this. Instead of leaving it as a fraction, and I want to write it with the symbol for division. So what do you guys think is going to happen as I begin to rewrite this? What should I write next? What do you think? Okay, so I'm going to start with the fraction 8 over 5. And then what? Divide, so the division symbol. So what is that? 8 over 5 divided by 25 over 4. Okay. So this is following the approach that we looked at earlier, right? You convert this to old-fashioned division symbol. You can rewrite this. And now we are looking at a brand new problem. So now we're looking at 8 over 5 divided by 25 over 4. We can attack this problem with keep, change, flip. So now we keep, change, flip. And as I begin to keep, change, flip, I keep the first fraction as 8 over 5. But now I change the division sign to a multiplication sign. And what's going to happen with 25 over 4? It's going to flip. It's going to become 4 over 25. Okay? 4 over 25. Now, we are going to look across and see if there's anything we can cancel out. For example, can I reduce the 8 and 25? Is there a factor of 8 and 25 that I can cancel out here? I mean, the only common factor is 1, right? There's no common factor between 8 and 25. What about a common factor between 4 and 5? No. Okay, so then we're just going to multiply across. 8 times 4 is 32, and 5 and 25 makes 125, and this is our final solution. Yep. 32 over 125. Okay. Any questions on this first example? All right. So we think we're ready for some pre-calc material now? Let's take a look. So right here. Okay. So now let's throw in some variables. Here is your example, x squared over 4. X squared over 4 divided by 3 over 2x minus x over 9. Okay, so now things just got very complicated. Well, let's look at all of our options before we, panic and then just leave the question blank. So we are going to rewrite this. That's the first thing. Let's rewrite this because as it is, it's very messy. Okay? When you have a fraction over a fraction, the lines start to blend together. You don't know which one is like which one's the numerator, which one's the denominator. So let's rewrite this. First, I'm gonna identify that this is my numerator and all of this is my denominator. So I don't want to mix it up. Okay, because if you mix it up, if you're like, oh, only the x is my numerator and then all this is my denominator, like it's gonna get really messy. So first, identify what you're looking at. Let's rewrite it. So x squared over 4 is my first fraction. I have x squared over 4 as my first fraction. And I am dividing x squared over 4 with the difference of 3 over 2x minus x over 9. Okay, this looks a little bit easier to manage, but there's a problem here. Let me close the door. And the problem that we have now is that our second half of the argument, the second half of the argument is a subtraction, which we are going to have to simplify before we can actually divide anything out. So that's where we're going to focus our attention to next is let's combine these together. And so for that, we have to refer back to what we learned in this last week, which is how do you subtract a set of rational expressions? Well, to be able to combine these, you need to have a least common denominator. Lucky for us, these are pretty manageable common denominators. We're going to figure out the LCD between 9 and 2x. Since there's nothing shared between 9 and 2x, we'll just combine them together. So it'll be the product of 9 and 2x. That's the LCD. So if that's the LCD, what do you guys think I'm going to multiply the first fraction by to get it to my LCD? By 9. So this is going to be by 9. And what am I going to multiply the second fraction by to get to the LCD? Well, it's whatever I don't have, which in this case would be 2x. Okay. So I'm going to rewrite this here to the right, just so I don't mix it up. 9 times 3 is 27. 27 over 9 times 2x minus the product of 2x and x, which will be 2x squared. Okay. Can you guys all see like what I'm multiplying by, or should I rewrite this? I know it's kind of messy. You good? Okay. All right, so we have a new fraction. This is the new fraction. And from here on out, this is the second fraction that we'll be dealing with. It's just this. All right. So let's rewrite this. Let's rewrite it. Let me go down here. I'm gonna write next to this. This is the new second fraction. Okay. Once again, this is the new second fraction. Okay. So let's rewrite this argument. We're gonna write it as the following. So we had x squared over 4, and now we are gonna keep change flip. So let's do times We're going to flip the second fraction, which is 9 times 2x over 27 minus 2x squared. Okay. And now this is what we're going to focus our attention to is, okay, now we're just multiplying instead of rational expressions. How do we go about it? Okay, well, if you guys think back to 202, which is when we did this stuff, we want to simplify before we multiply all of it together. And so we have to figure out, okay, well, what can I do here with these terms? So 9 over 2 or 9 and 2x, they're kind of already separated, so I can't do anything with that. 4, I could probably cancel the 4 with the 2, but for sure this one we'll have to do something to. Let me see if we can. No, we can't do anything with 27 and negative 2. There's no common factor between 27 and negative 2. And we can't take out an x. So really, the only thing we can do here is maybe what? Just cancel out this 4 and this 2. So 2 goes into 2 once, and this becomes a 2. Can we do that? That looks good to me. This is the 1. So now we can just multiply across. X squared and 9x gives 9x to the third. And then 2 times, you're going to have to kind of like distribute. Right? It's 2 times 27, which is going to give you 54. And 2 times negative 2 gives you negative 4x squared. And is there anything else we can do? No. All right. This is our final answer. It doesn't look like you guys have to find excluded values, so you no longer have to worry about excluded values, which is good. So let's work for you. All right. Yes. So it's the product of x squared and 9x. I got rid of the 2 with this 4. Yeah, 1x. And then the product of 2 with this gives you the bottom. Yeah, question? Since we are multiplying everything together between 9 and 2x, like I'm able to rewrite the, where can I write this? I'll do it. Like 9 times 2x, because this is being multiplied, I could, split all this up. 9 times 2 times x. And then this would be the top, a bunch of stuff here in the bottom, times a bunch of stuff here on the top, and 4. Like, I can, okay, I'm not rewriting this, but you could rewrite the 4 as 2 times 2, and then, you can cancel that out, which is what we end up doing. If you feel like you need to do those little steps, please do it. Or if you want me to show you the steps, I can show you the steps. It's just they're very small steps, so it would like take a lot of time. But that's kind of behind the scenes what's happening. Okay, so that's where we get the 2, and that's where we get the 9x. Yeah, so like here we had x squared, so it's the product of x squared and 9x. And then the bottom we had a 2 and the product of 27 minus 2x squared, which you would then like distribute. And that's how we get that. Yeah. Is that better? Does that make more sense now? Okay. In the next problem, I'll show the little steps. All right. Any other questions on this one before we move on to the next problem? Okay. Let me go where? Down here. Okay, here is your next problem. Let's write this down. 16 over x minus 4 over 5 divided by, can you see that? Yeah. Divided by 4 over x squared plus 25 over x. Okay, so a lot of steps we're going to do here. All right, you guys ready? Okay, let's get started then. First, let's begin by establishing that the top is my numerator and the bottom is my denominator. So that way I know I'm looking at, this is the top, this is the bottom. Let's deal with them individually. So for the top, we are going to have to do LCD to figure out how to combine this. So the top, what is the LCD of x and 5? What is it? Just x? LCD. What LCD? What is the LCD that I can make? I'm not asking for the factor. I'm asking what LCD I can make between 5 and x. 5x. So the LCD is going to be 5x. So if the LCD is 5x, then I have 16 over x and 4 over 5. I'm multiplying the first fraction by what to get 5x? By 5. Top and bottom. Okay. What am I going to multiply the second fraction by to get 5x? If I have the 5, I'm missing the x. Okay. All right. So let's simplify this. 16 times 5 is the same as 8 times 10, in case you didn't know. That's going to be 80 minus 4x over 5x. And I'm going to highlight this just to show you that this is like my new first fraction. I'm highlighting the whole thing so that you know it's like, yeah, this fraction is just the numerator. Let's focus our attention to the denominator now. Was anyone writing that still? The 5-1? Are we good? Okay. So now let's do the same thing with the denominator. So now we're doing the LCD between x squared and x. What LCD can I make between x squared and x? Keep in mind, if you already have something in common, you don't need to include it again. What's in common between x and x squared? An x. So I can keep this as x squared. All I would need is another x on this side. See how that works? So the LCD will have to be x squared. So we have 4 over x squared plus 25 over x. And like I said, this already has the x squared, so we don't have to do anything to the first fraction. It's only the second fraction that we have to modify. And we're going to modify the second fraction by multiplying top and bottom by that missing x. Okay. So 4 is going to stay the same. 25 and x will give you 25x. So that's going to be 4 plus 25x over x squared. And this is your new second fraction. Any questions so far? Okay, now remember, it's the numerator being divided by the denominator. So we're going to rewrite this now. So it's the numerator, which is 80 minus 4x over 5x. It's this divided by the second fraction, which is 4 plus 25x over x squared. Okay. So like this is like the new problem basically. Let's keep change flip. $80 minus 4x over 5x times x squared over 4 plus 25x. Okay. All right. So before we multiply straight across, we are gonna try and see if there's anything we can kind of cancel out. Between 80 and -4, I could probably take out, a 4, or yeah, I could take out a 4, but I don't know if it's gonna cancel with anything from this side because 25 and 4 don't really have a common factor. But x squared and 5x, I could factor this. I'm gonna rewrite this, and I'm gonna do it the long way so everyone can see what's happening. So I'm going to keep 80 minus 4x how it is, but I'm going to rewrite 5x as the product of 5 times x. And I'm going to split x squared as the product of x times x. Okay, do you guys see what happened there? Is I split up 5x and I split up x squared, and the reason why I'm splitting that up is so that I can cancel an x out. I can cancel this x with this x. That's why I just did all that, right now, the split. So we have the product of x and 80 minus 4x, and the product of 5 with 4 plus 25x, which we're going to have to distribute. I'm showing like every single step. Okay, that's why this is very long. If you feel like you understand what's happening in between, you don't have to write these many steps. Okay. Well, x times 80 is going to give me 80x. And x and -4 gives me -4x squared. 5 and 4 makes 20. 5 and 25 makes 125x. And this is good. This will be our final answer. Yep. All right. Any questions on this problem before we move on to the last question of the day? I'm only going to do one more example. Yeah? How do you feel about doing the next one on your own? I can walk you through the first part, and then I'll let you take it from there, because it is going to be pretty difficult. All right, let's take a look at the next one, last one. I saved the best for last. All right, here it goes. Ready? X divided by x plus 4 minus x plus 4 over 2x. That's just the numerator. Okay. Yep. Here goes your denominator, x plus 4 over x squared minus 4 over x plus 4. I'll walk you through like the first 3 steps and then you'll take it from there. All right. Give me a thumbs up when you're ready for the next step. Okay. So let me start highlighting. This in yellow represents only my numerator and purple represents only my denominator. I want to combine my numerator, but I have to find the LCD between x plus 4 and 2x. So x plus 4, 2x, there's nothing in common. Why don't we combine them? Our LCD will be the product of 2x and the product, 2x and x plus 4. That will be my LCD for the top. We're only going to focus our attention one part at a time. So we're only doing the top right now, but then we'll come back to the bottom. Okay, so if my LCD is 2x, x plus 4, then I got to figure out what to multiply my fractions by. So let me rewrite my fractions. I had x over x plus 4, and then I had x plus 4 over 2x. With a minus in between them. Okay. So if this is my LCD, I got to figure out what I need to multiply my first fraction by. I already have the x plus 4, but I'm missing the 2x. Okay. So the first fraction gets multiplied by 2x. While the second fraction gets multiplied by what? Well, it has the 2x, it's missing the x plus 4. Okay. All right, let's go ahead and multiply. Well, 2x times x is easy. Because 2x times x gives you what? 2x squared. There's a part that worries me though. And it's the next part. And the reason why this is like a point of like watch out is because you are multiplying 2 binomials. And this is also something I noticed on the test. Whenever you guys multiply binomials, you have to either use distributive property like FOIL, first, out, in, and last, or the area model. You can't just multiply x with x and 4 with 4 and say, yeah, this is x squared plus 16. Because you're forgetting that there's a middle term in between. All right, so we have to multiply this the long way. So let's multiply this the long way. So we have no space. That's what we have. Hold on. Where am I going to write this? Here, let me erase this 2x squared. Let me get it out of the way. Area model. X plus 4 and x plus 4. Okay. X plus 4, x plus 4. Let's take a look. Well, x times x gives you x squared. 4 times x is 4x. So this is 4x, 4x. 4 and 4 make 16. And all of this is just for this part right here. All right. Are we good with that, with the area model part? Okay. So I'm going to rewrite it down here. I think that's probably what's going to work best. Okay, so we said we had 2x squared minus, what's going to happen is all of these, I'm going to make them negative. So the x squared is going to become negative. So 2x squared minus x squared. 4x and 4x, which is 8x, is going to turn negative. Negative 8x. And then 4 and 4, which is 16, will become negative 16. All of this over 2x, x plus 4. I don't want to box this because then you're going to think it's the final answer. I'm going to highlight it yellow so you know that it's the, well, hold on. We got to combine like terms. I don't know if I want to do this right now or later. We'll do that later. We can do that later. What's up? Oh, you're new? Okay, yeah, I have a seat in the back. Okay, so I'm going to highlight this in yellow so you guys know that this is my numerator, new numerator. Now we have to deal with the denominator. Okay, so let's do it. Okay, now we're dealing with the denominator. Let me just draw an arrow so you guys know what happened. All right, let's take a look. So x plus 4 over x squared minus 4 over x plus 4. LCD. What is the LCD between x squared and x plus 4? What was that? It's not just x squared. But good try. X squared and x plus 4. Okay, this is the LCD. X squared and x plus 4. Okay, so what am I going to multiply my first fraction by? I have the x squared. What am I missing? X plus 4. And in the other side, I'm missing x squared. Very good. Very good. All right. We don't have to do x plus 4 times x plus 4 the long way again because we already did it on the other side with the area model. So you just kind of write what it was equal to. So this is going to be the following. Now this becomes, we said it was x squared plus 8x plus 16 minus 4x squared over your LCD of x squared and x plus 4. Okay. Because the other one we were subtracting them. We are subtracting the 4x, but the other side, we were subtracting x plus 4 times x plus 4. So it turned all of these negative. Yeah, which part? Okay, so she asked, I'm guessing you were asking this. Why is x squared plus 8x plus 16 positive here when it was negative here? The reason why is because for the top, we're subtracting the product of x plus 4 and x plus 4. So with this minus here. Because of a negative, it's going to turn every number here negative as well. So that's how you get negative x squared, negative 8x, negative 16. On this side, though, We're not subtracting it. We're subtracting the other part, this second part. That's why. Yep. All right, we're almost done. So this is the new numerator. Or sorry, denominator. Okay. So now let's rewrite. All right, so rewriting this, we have 2x squared minus x squared minus 8x minus 16 over 2x and x plus 4. Divided by this fraction here, which was x squared plus 8x, so x squared plus 8x plus 16 minus 4x squared over x squared and x plus 4. I'll let you guys take it from here. I did the heavy lifting. All you have to do is skip, change, flip, and then combine like terms and the rest of that. Because if I do combine like terms, I'm gonna have everyone ask me what I just did. So I'll let you guys do it. Even though I know it's easy, but you do it on your own.